sine wave we will be using to demonstrate the oscilloscope will be the product of a simple series circuit, as you can see right here. The circuit will consist of one 680 ohm resistor and one 22 nanofarad capacitor. We'll be using a function generator to produce for us a sine wave with an amplitude of 5 volts at a frequency of 1 kilohertz. One point I would like to make about this circuit is how we obtain the phase shift across this capacitor. And we do this by arranging the circuit so that the capacitor is first in line after the power source, and we'll be connecting the positive lead to channel 2 to the back leg of that capacitor in order to shunt out the resistor.
Safety features. A very important issue when dealing with any electrical components is your safety. Rule number 1, make sure your power is off from the power source and changing any components of your circuit. When measuring different components, change the leads on your meter. If not, you and your meter will be burned because you will burn a fuse. When using a function generator, I recommend using alligator clips instead of direct leads because you will get a better connection and less bare exposed wire.
Today we're going to demonstrate the operation of this oscilloscope, the Tektronix TDS 2002B model. And to help us demonstrate this oscilloscope, I'm going to be explaining some basic functions of it. As you can see, the display of the oscilloscope provides some basic information. At the bottom of the screen you can see channel 1, which is this port right here where you connect the B&C connector to get a sine wave from any kind of circuit. This number right here represents 500 microseconds of each block horizontal position. And the 2 volts represents the vertical time. Each block represents 2 volts. You can measure the distance and the size of the sine wave by going to cursor, this button right here, and making sure it's the channel 1 sine wave that you want to measure, and the type of cursor you want. You can go horizontal to measure the peak voltage, and then you change the cursor to for the bottom cursor. So that will be a peak to peak. The delta V will be the measurement of that peak to peak, 14.3 volts from top to bottom. If you wanted to change it to the time, if you wanted to measure the phase shift of the sine wave, you can measure, change your cursor to here, to the end of 1 cycle, changing cursor 1, and that'll be 1 cycle. And you can see it here, 1 millisecond.
Basically, we're going to explain some other features of this, and what we want to do is plug in one of the leads from the signal generator into channel 1. When you first get it, you'll basically see this, and what you want to do is hit the auto set button. Get your signal like this. From here, you can do a lot of functions or a lot of display things by moving the volts per division, which you go up, it'll make the wave bigger. You get smaller, the actual voltage divisions actually get bigger. So to make it bigger, the voltage divisions go smaller, and it's opposite to go bigger, or smaller to go bigger. You can also move the vertical position with the vertical position switch, and you can move the horizontal with the horizontal switch to line it up. Now, to have another signal come in, you hook it up to channel 2,
and you hit auto set.
And it says it's empty all day.
And you'll have two signals. And to control both of them, it's kind of the same thing to overlay. You use the vertical position. Okay. So what we're going to demonstrate here is the ability of the oscilloscope to measure the phase shift with the incoming signal from the signal generator across the capacitor. So the first thing we want to do is put on the cursor button. You want to hit type to hit time. You want to be on cursor 1, and cursor 1 we want to have on the leading edge of the incoming 1 kilohertz signal. Like that. For the second cursor to move, we want to hit cursor 2, and we want to move that to the leading edge of the waveform off the capacitor, which is there. And basically, there is an equation, which is division of theta over the division of times 360 degrees. So our division of theta is right up here, 260 microseconds. Our division of time is the whole cycle, which is 1 millisecond times 360 degrees, which gives us a 90 degrees phase shift.